So now that we've talked about addition, subtraction, multiplication, and division in the whole numbers, we're going to move into chapter 4, which is all about number theory. In section 4.1, we're going to talk about divisibility. So we say an integer is even if it has a remainder of 0 when we divide by 2. Otherwise, the number is odd. We say that 3 divides 18, written as 3 with this line, 18, because the remainder is 0 when 18 is divided by 3. So don't confuse this by writing 18 divided by 3. So that's read 18 divided by 3. This is read 3 divides 18. We say that 3 does not divide 25, and we write that with a little slash on the line here now, because the remainder when I divide 25 by 3 is not 0. In general, we're going to write B with that line A if B divides A. So if A is a non-negative integer and B is a positive integer, the language that we're going to use is that A is divisible by B, or B divides A, if and only if the remainder is 0 when A is divided by B. Okay, so for any whole numbers A and B where B is not equal to 0, B divides A if and only if there's a unique, that should say whole number, Q, such that A equals B times Q. Now notice, if you remember the division algorithm, what we had was in general A equals B times Q plus R, where R is your remainder between 0 and less than B. And so all this is saying is that my remainder is 0. If B divides A, then B is called a factor or a divisor of A, and A is a multiple of B. So we saw that 3 divided 18. So we say that 3 is a factor. Oops. Or divisor of 18, and A, 18, is a multiple of B. You need to be fluent in this vocabulary. All right, so let's determine if the following is true or false. So the first statement says 5 divides 16. Is that true or false? Well, that's going to be false here, since the remainder when 16 is divided by 5 is not 0, right? So the remainder is not 0. All right, what about B? Is 0 even? Well, we say a number is even if 2 divides that number. So think about what is 0 divided by 2. This is one of the things that we talked about in the last unit. 0 divided by 2 is 0. And so 2 does divide 0, so 0 is even. For all whole numbers A, 1 is a factor of A. Is that true or false? That's going to be true, right? For any whole number A, 1 divides A. Since A divided by 1 is always just A. What about D? 6 does not divide 15. Is that true or false? This is true, since there is a non-zero remainder. Or 15 divided by 6. How about this one? For all whole numbers A squared divides A to the 5th. Well, let's think about what happens when I take a to the 5th divided by a squared. That's going to give me a cubed because a squared times a cubed equals a to the 5th. So I get a non-zero remainder, so this is true. For all whole numbers n, 3 divides 6n. Well, again, let's think about what's happening when I take 6n divided by 3. Well, what is the solution to this? This is going to give me 2n because, again, let's use the multiplication property because 3 times 2n is equal to 6n. All right, so again, I have a non-zero remainder, and so this is true. What about G? For all whole numbers, a, 0 divides a. Well, in the last chapter, we talked about a divided by 0. What did we find? This is undefined. So does 0 divide a? No, it does not. So that's false. And lastly, 0 divides 0. Again, we saw in the last chapter that 0 divided by 0 is undefined. So this is also false. All right. Okay, so let's look at some properties of division. If I have whole numbers a and d, if d divides a and n is any whole number, then d divides na. So we saw that when we had 3 divided 6n. Here are some more properties. So for integers a, b, and d, where d is non-zero, if d divides a and d divides b, then d is going to divide the sum a plus b. If d divides a and d does not divide b, then d does not divide the sum a plus b. If d divides a and d divides b and a is bigger than b, then d divides the difference, a minus b. And finally, if d divides a and d does not divide b with a bigger than b, then d does not divide their difference. One more, if d divides a does not divide a, d divides b, and again a is bigger, then d does not divide their difference. Okay, so let's try applying that. Let's classify each of the following again as true or false, where x, y, and z are whole numbers. So I have 3 divides x and 3 divides y. Can I conclude that 3 divides x, y? Well, let's think about what that means. So since 3 divides x, there is a q, whole number, such that 3 times q equals x. And similarly, since 3 divides y, there is a, let's say, p, such that 3 times p equals y. So what does that mean about x times y? Well, I can write x times y as 3 times q times 3 times p, which is 3 times q times 3p. So here is the whole number that I multiply by 3 to get xy, which means that 3 does divide x times y. So this is true. What about b? If 3 divides x plus y, then 3 divides x and 3 divides y. What do you think? I suggest that you pause the video and think about this one yourself and then come back to see what I got. Well, let me give you an example. 3 divides 6, right? Because 2 times 3 equals 6. But I could write 6 as 4 plus 2. But 3 does not divide 4, and 3 does not divide 2. So this is false. What about C? If 9 does not divide A, then 3 does not divide A. So if 9 does not divide A, that means when I try to divide A by 9, there is a remainder. Again, you might try thinking of some examples. This is C, not B. So let's just stick with 6 here. 9 doesn't divide 6. So can I conclude that 3 doesn't divide 6? Well, no, we've already said that 3 does divide 6. Okay, so this is also false. All right, so if a statement is false, it's enough to find one counterexample. If a statement is true, you need to show why it's true. Okay, now I'm going to erase so you can see the print here. Let's look at another example. We can use the rules to determine divisibility quickly. So does 17 divide 1734? Well, can I write 1734 as something more useful? Sure, I can write 1734 as 1700 plus 34. And why is that more useful? Because it's easily identified as two numbers that are divisible by 17. So 17 divides 1700 and 17 divides 34. And so by our property, if 17 divides A and 17 divides B, then 17 divides A plus B, or 1734 here.